Welcome to this explainer on the NCP-MCI 7.5 certification. If you're an infrastructure admin gearing up for the exam, you are in exactly the right place. Today, we are laser-focused on Objective 5.5, which covers key management options. Now, we're going to set a nice, steady, methodical pace for this explainer because, well, this specific subtopic is pretty notorious on the exam. It mixes the strict, rigid rules of physical hardware with the deep flexibility of software-defined encryption. And let me tell you, the exam absolutely expects you to know exactly where those boundaries lie. Data at rest encryption isn't just about checking a compliance box anymore. It's about deeply understanding architectural constraints. So by the end of our time together today, you're going to have a rock-solid mental model of exactly how key management servers, or KMS, are configured and managed centrally. Here is our architect's blueprint for today. We'll start with why key management matters, move into a walkthrough of the 4 KMS options, tackle some tricky exam traps and edge cases, and wrap up with the key facts you absolutely need to memorize. Okay, let's dive right into this. Section 1, why key management matters. When we're talking about data at rest encryption, we are ultimately talking about securing the physical storage of your clusters, right? To really understand how Nutanix handles this, we first need to master 2 foundational acronyms that drive the entire process. The first is the DEK, or Data Encryption Key. This is a symmetric key, specifically something like an AES 256 key. I want you to visualize the DEK as a massive, heavy-duty padlock that physically locks down the terabytes of raw data sitting on your drives. Because this DEK is doing the actual heavy lifting of encrypting and decrypting real-time read and write operations, it operates locally, and it operates exceptionally fast. But here's the catch. Having that heavy padlock right there on the drive creates a vulnerability if the key to open it is just left lying out in the open. It needs a robust, separate layer of protection. And that brings us to our second foundational acronym, the CAKE, or Key Encryption Key. If the DEK is that heavy padlock on the drive itself, I want you to think of the CAKE as the ultimate master key. And this master key is locked away securely in a totally separate security office. The CAKE's sole purpose in life is to encrypt and decrypt the data encryption key we just talked about. This separation of duties is an absolutely vital concept for your exam prep. When you set up a key management server, a KMS, that server does not touch your actual data. What it is actually managing, securing, and rotating is the CAKE. All right, moving right along. Section 2, walkthrough of the 4 KMS options. Now, what's really interesting to see is how this translates into the actual interface. When you open the Prism Central UI to configure your KMS, you're presented with a very specific set of options to manage this workflow. For instance, when you configure an external KMS, the system establishes absolute trust by exchanging certificates. Your Prism Central instance securely stores that configuration. And here's the best part. Because this is entirely centralized, you can apply these configurations to any supported cluster in your environment without having to log in and configure it on every single individual cluster. It is a massive operational time saver for admins. So let's break down the exact 4 options you have at your disposal. First, there's native KMS local, which is very often referred to as LKM, or Local Key Manager. This localized service avoids any dependency on external managers, keeping the whole shebang self-contained within the cluster. Second is native KMS remote, which lets you keep your keys secured with a registered remote Prism Central instance. Third, we have the external KMS, or EKM. This uses entirely separate third-party key management servers. And a quick note on EKM, Nutanix strongly recommends having 2 or more of these for redundancy, just to prevent a single point of failure. Finally, there's Cloud KMS. For a concrete example here, imagine you're extending your data center into AWS using Nutanix Cloud Clusters, or NC2. You absolutely would not want to rely on an on-prem physical key manager for your highly dynamic cloud workloads, right? That's where Cloud KMS really shines. It's a Prism Central only option that lets you securely integrate directly with your cloud provider's KMS, like AWS KMS or Azure Key Vault, so you can natively manage those keys right where the workload actually lives. Now, during a cluster's lifecycle, requirements are going to change. Imagine a new super strict compliance audit forces your company to upgrade from a local key manager to an enterprise-wide external key manager. If you get a scenario question on the exam asking how exactly to change the KMS type, you have to know this click path. First, from the Prism Central application switcher, you'll select Infrastructure. Then you navigate to Hardware, and then Clusters. From that list view, you select your encrypted cluster. Click Actions and select Manage KMS Type. You'll then pick your new external KMS and just click Change KMS Type. It's pretty amazing that Nutanix allows you to switch between these supported types without any downtime. But listen to me carefully. As a strict operational rule, you should always meticulously back up your encryption keys before and after making any change to your KMS type. Let's look at another concrete architectural scenario, one that the exam absolutely loves to test. Imagine you've got a standard 3-node cluster in your main data center, and you have a 2-node robo deployment out at a remote branch office. That 3-node cluster, it can easily utilize the native KMS local or LKM. But why is that? Well, the underlying architecture of the local key manager relies on a distributed system that strictly requires a 3-node quorum to ensure key availability and consensus. If you only have 1 or 2 nodes, like at that robo site, they mechanically cannot form the necessary distributed consensus. Therefore, 1-node and 2-node clusters are strictly locked out of LKM. For those edge sites, you have to select either native KMS remote or an external KMS. Okay, before we move forward, let's pause for a quick knowledge check. Picture this. Your Chief Information Security Officer knocks on your door and mandates dual encryption to pass a massive upcoming security audit. Meaning they want data at rest encryption enforced at the physical hardware level using self-encrypting drives, plus software-only encryption layered right on top of that. How does that strict mandate impact your KMS choice? Which brings us perfectly to Section 3, Exam Traps and Edge Cases. So answering that CISO's request, dual encryption requires an external key manager, full stop. On the exam, any mention of combining SED and software encryption must trigger an immediate reflex answer in your brain. External key manager. It is mandatory. Furthermore, here's a massive trap you've got to avoid. Nutanix does not support the use of the local key manager alongside a third-party external key manager. They are entirely mutually exclusive. You have to commit to the correct architectural path based on your exact encryption and hardware requirements. No mixing and matching there. Straight from the security guide, here is another huge constraint you've got to memorize. If a scenario presents a Prism Central KMIP-based external key manager, immediately cross SEDs off your list of possibilities. KMIP-based key managers configured on Prism Central support only software data at rest encryption. They absolutely do not support SED-based data at rest encryption. And why? Because the KMIP standard implementation here is focused purely on software-level key management. It simply doesn't handle the low-level hardware unlock commands required to spin up physical self-encrypting drives. It is software only. Here's one more critical edge case for your notes. If you're using Prism Central Backup and Restore, PCBR, there is a strict incompatibility you need to know. You cannot enable or switch to native KMS remote on any Nutanix cluster that is actively configured as a backup target for PCBR. Now, why does this restriction exist? It prevents a catastrophic circular dependency. Think about it. If your central Prism Central instance goes down and your remote backup cluster is relying on that exact same Prism Central instance to remotely unlock its storage drives, well, the backup cluster would remain locked. You wouldn't even be able to access the PCBR backups to restore Prism Central in the first place. It would completely lock you out of your own environment. All right, homestretch. Section 4, Key Facts to Memorize. We have covered a lot of deep architectural ground today, so let's synthesize this into a rapid-fire drill. If you memorize anything from this explainer, make it this matrix. Let's review them methodically. To run local key manager, what's the absolute minimum cluster size required for quorum? That's right, 3 nodes. If you're deploying a 1 or 2 node Rabo site, what are your only 2 KMS options? Remote KMS or an external KMS? If your CISO demands dual encryption combining both SEDs and software, what must you deploy? An EKM. And finally, if a cluster is serving as a PCBR backup target, what KMS option is completely off the table to prevent a circular dependency? Native KMS remote. To wrap things up, I want to leave you with a final thought experiment to really test your mastery of this topic. Imagine that 2-node edge site we discussed earlier eventually scales up, and you add a 3rd node to the cluster. How does your KMS architectural flexibility change? Well, based on what we've covered, you know that hitting that 3-node threshold establishes quorum, which suddenly unlocks the native KMS local option. You can then seamlessly switch away from a remote or external KMS right from Prism Central. But here's the question you should be asking yourself next. Once you actually switch to LKM, how do you handle key rotation in a localized environment without disrupting your active virtual machines? Think about that operational challenge as you continue your exam prep. Thanks for joining me on this explainer, and best of luck on your NCP-MCI exam.